And we are live. Hello, guys. How are you guys doing? I hope all of you guys are okay and you guys are getting used to this quarantine life. I posted some polls. Take a couple of seconds to answer the questions on there. How do we have a question? We didn't even start yet. Okay. We'll wait a couple of seconds until everybody else shows up. I don't know what you mean by sharing the slideshow, because those slideshows will be uploaded to the stream. Like there will be up there, you will be able to access them after the stream is over. But you guys are able to see it right now, right? Yeah, okay, yeah, okay. So yeah, you will be able to get the link to the slides through Fiveable. So if you after the stream, in a couple of hours, if you go back to the stream on Fiveable, you will scroll down and you will see there's a shared link to the slide to the slides that are being presented right now. So yeah, but I will have to upload them, so it will take like a couple of hours. Just depends on when I get it done. But yeah, so let's get started. Okay, so today we're gonna be talking about population densities, and we're not really gonna cover a lot of migration, but we're gonna be talking about the population densities and um, population clusters. And again, I didn't introduce myself. I'm Rita, and I'm a sophomore at high school. I took AP HUG last year, and I did pretty good on the test. Let me see what you guys answered for the polls. So we have confident about the test, kind of frightened about the test. Is this your okay? So okay, because usually this course is usually freshmen take this course, so it would be your first test, and I think it would be a very I think it would be a very a good intro, like AP exam for the AP exam, because it's relatively not as difficult as the other AP classes. So yeah. So okay. So those are the weekly stream calendars. Okay, so we have what did you take on the test? I got a 4 on the test, and then yeah, I got a 4 on the test. Those are the weekly stream calendar for Fiveable. So if you're taking any other IP classes, like you're saying, taking biology, you can check in on these days, right? On Mondays, we have math and English streams. On Tuesdays, we have social sciences. On Wednesdays, we have science. And Thursday, we have history. And guys, you guys have, let me see, I think you guys have 22 days left before your test. You have 22 days before your test. So take it seriously, and you got it. You got it. Don't stress out. You got it. And again, don't forget to follow Fiveable at Twitter, Instagram, and YouTube at Think Fiveable. And then we've been talking about this, but I mean, it's very important to know, right? Also, okay, so your test is going to be on May 12th, right? We talked about that a lot. May 12th, there are going to be 2 questions, 2 FRQs. And I don't know if you guys know, but the College Board has been sending emails. You're sending emails so you can be able to to confirm the date you're going to be taking the test. So check in with that. If you didn't receive any emails from the College Board, you can go back to your college, like the College Board settings, and make sure that the email you put in that is connected to your College Board account is the same email you're using right now. Check that out, and you should be able to confirm the date before May. So yeah. And guys, don't stress out over the test. Like you guys got it. If you guys have been so like if you guys are on here, right? You guys actually care. You guys have been doing all the work the past semester, the past year, and you guys will do pretty good. Just don't stress out, and you got it. And just review as much as you can, but don't stress out. Do not stress out. Stressing out will just kill you. Don't stress out. Please don't stress out. So yeah. So today we're gonna be talking. We're gonna be talking about factors that affect population clusters. We're going to be talking about consequences of population densities. We're going to talk about the different densities, the different densities that uh, geographers used, and what these different densities give us. What information these different densities tell us about a region. Second. Okay. So, okay, so understanding where people live. So there are like many factors that affect where people are located, right? Where people choose to live. So there are physical factors and there are human factors. Physical factors are like climate, landforms, and water bodies. So for example, like if you don't like the cold, like if you don't if you want to move somewhere, right? If you don't like it to be very cold and you don't like the cold weather and the cold mood, right? You won't choose to live in Canada or somewhere in the north, right? Because it's cold, as opposed to like in California, especially I'm here in Southern California, we're very blessed with the weather. And the weather is like great. You get 4 seasons in like a whole week, right? You can experience the full four seasons in like a day or two. So that's a blessing. That's great. So what climate affects the people how live. I mean, if you have like special health conditions, that will affect too. Like if I don't know if you have like if you're an old guy, not an old guy. Okay, if you have like for example arthritis, you're not gonna be living in somewhere that's cold because that's gonna influence your health, right? There are many factors that affect that. So water bodies too. If you're living next to a lake, next to an ocean, whatever you prefer. How these factors kind of influence the people's decisions, but obviously the human factors I think are the ones that actually affect human decisions more. Culture, economics, history, and politics, those are like important ones. Culture, like of course you want to be living in a place where your culture is accepted, you're not being discriminated, right? Economics is a huge one. Economics is, I think, is the first reason why people migrate. We're talking about it, the first reason why people actually migrate for economic reasons, to look for jobs and to look for opportunities. You're not gonna go live in a place where you're not gonna find jobs. That just doesn't make sense. How are you gonna live, right, without money? History of a place, a lot of people are still living in places where they grew up, right? But some people might choose to, I don't know, go to other places because of the history of the place, right? The history of the place and whatever meaning that has on them, right? And politics and economics, I think, are the like major factors, right? Politics is like very important, right? You're not gonna be living in a, you're not gonna want to live in like a place where you don't have freedom, right? Like example, like North Korea, you don't really want to live there, right? Where the government basically controls everything. You want to live in a place where you're free, you have freedom, and you can express your opinion, right? Your opinion freely. And then factors that talk about population clusters vary according to a scale of analysis. So obviously, like scale of analysis means how large is the area you're actually like studying. Like, are you studying a state in the U.S. or are you studying the states as a whole, right? So that varies. These factors vary, right, from how how big is the how big is the area, the region you're studying. That's basically what they're saying. And you have, when studying map, okay, this is not really related, but when studying maps, it's very important to understand the scale, right? How, like, on the, like, somewhere on the margins, on the corners, they tell you the scale. So, like, 1 centimeter is like 10 miles, whatever. It's very important to understand the scale to be able to actually understand the map and what's being communicated. What information is the map giving you? Because you have to understand how big is the area you're studying, even on the map, to be able to fully understand all the information that the map is giving you and analyze this information, if that makes sense. So, okay. So population clusters. There are 4 main population clusters on the globe, on the world, right? In the world, we have South Asia, we have Southeast Asia, we have East Asia, and we have Europe. On the map here, you can kind of tell, you can tell those you can kind of identify those population clusters. The darker the color, the more populated the region is, right? So you have South Asia. Okay, so do you guys know what's the not regions, right? But um, what are the three countries that are mostly populated in the world? You guys should be able to know that, right? The mostly populated countries in the world, countries that the countries that have the most people living in. Some answers, guys. Answer. Put something really fast in the answer something section. In the answer section, guys, please. India, China. That's right. India, China. Those are the largest. The largest two. They have the most people living in India, China, and then what else? What's the third one? What's the very obvious one after India and China? No, it's not Indonesia. It's India, China, and then we have it's China, India. Is it China? It's China, India, right? China is the most people. China, India, and then we have the United States. United States has the most people living in, right? But like, it's we're talking about population density as a whole, so amount of people living. But if you look at the like, it doesn't mean that because like it's not like if you think of populated areas like India and China, right? The places where it's very clustered. There are a lot of people living in. A lot of times, those countries are less developed because of the lack of resources. But if you look at the U.S. for as an example, it's the third most populated area. But the difference is that the United States, the population in the States is not really okay. I don't want to say clustered. It is clustered in some regions, but the area is larger, so people are more spread out, diffused around on the map. If that makes sense. Because doesn't mean if a region is very populated, that means it's not developed or it's developing. A lot of times that the case applies. Like China and India are kind of like maybe in the third right? In the third um, stage of the transitional model, but it doesn't really. You have to look at other factors that affect that. Okay, we kind of went out of. Okay, I'm kind of confused too. Okay, forget what I said. I'll just continue. We'll talk about it later because we're gonna be talking about population densities. But I'm saying that it doesn't just because the location, a region is very populated, it does not really give us enough information to talk about if the region is developed or developing or like if you compare India and China, for example, they have a lot of people living in them, right? But the economic and social and like even the stage they're in, the demographic stage they're in is very different, right? So let's just move on, and then we'll talk about the population densities in the next slides. Okay, so we have South Asia, right? We have India, Pakistan, the most populated countries in South Asia. Guys, very important to know these regions. Very important because on the test, they're not like if you're gonna compare two like countries, then you're not obviously expected to know like the exact population density of each region, right? But you have to know what region of the world is very populated, that have a lot of people in, and what region of the world is not populated, right? And why is that? How does that tell us? What does that tell us about the development of the region, right? The resources available in the region, right? It tells us a lot about the environment too, right? How is the environment affected by this popular by this by the population? So we have Southeast Asia that includes Indonesia and the Philippines, the largest two, and then East Asia, which includes East China and then Japan and then the Korean peninsula. And then we have Europe, Germany, and France, the most populated countries. So make sure to know that, guys. That's very helpful to understand, like, get a larger. You don't really have to know details, right? You don't really have to know details about population of each country, but you have to know the major regions where, yeah, where most people are located, where most people are located. And what does that tell us? So we have consequence of population distribution. So what is the more populated and less populated areas tell us, right? So the less concentrated population, right? This is generalizations. Well, not really. Okay, never mind. I don't. Okay, so less concentrated populations mean that people are kind of diffused more, right? Like people are not living in clusters, right? They're not like maybe there won't be apartments, right? People are not living on top of each other. Maybe they would be like separate homes, independent homes, right? Because people are kind of diffused and there's more land, right? So people are not clustered together. So that might result in lack of services. When there are less people, there are less schools, less healthcare because there's less people. Less people means less children. Less children need to be educated, so that therefore there's less schools. And then healthcare, the same thing. There are less people, and less people are getting sick, and it doesn't from economic reason, it doesn't really make sense to build a lot of hospitals when there's not a lot of demand, right? There are not a lot of people getting sick, so there's no point of making hospitals. And that might mean that people that living in those like diffused and those less concentrated areas where people are living very like independently in isolation, that might mean that they would have to travel long distances to be able to access some of these resources, right? To be able to access some services. For example, like I'll give an example. Okay, I'm living in a no and an, I'm not living in a like a isolated region, right? But like that's getting into okay. So if I got a surgery last year, right? I tore my ACL playing sports, so I got an ACL surgery, and I had to go downtown LA to the main center, to the hospital where they provide that service to be able to get that surgery. So my distance was not that long, right? I drove like for 15 minutes, 30 minutes max, right? Because I'm living so close to the main main center, right? But if somebody that lives in a very isolated region, that service for them to be able to access that service might take them hours, right? They might take them hours. So that's another disadvantage. And then obviously isolation, right? People are more isolated. They're not really like in contact because people are living from distance, right? And then a great example of that, I would say, to understand that is the US Midwest. If you look at it, literally more than half of it is farmland, right? So people there, like farmer, like you don't really see people talk like the services there are very few, right? Because there are not a lot of people that demand it. It's mostly farmland and animals, right? So that would be a great example of a less concentrated area. But if we're talking, you know how we were talking about the scale of analysis we're talking about, we're looking at the U.S. Midwest only, right? But just because like if you look at different regions in the U.S., right, they're populated in a different way, right? So the Midwest is very there are not a lot of people living in the Midwest, right? But while like in LA and New York and Chicago, for example, those are the largest two cities in the US. Those are the most populated, where the most businesses and most stuff are going on, right? So we have to look at the analysis, like we have to look at the scale of analysis. and the scale will differ based on what we're studying. Okay, that makes sense. I think that makes sense. I hope that makes sense. Guys, if you have any questions, just let me know. Type something in the question section if you have any questions. Please, 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 please. Okay. So on the other hand, we're talking about less concentrated area, right? If you talk about densely populated locations, right? Oh, sorry guys, there's a typo. Okay. So densely populated locations, what does that tell us? Okay, what does that tell us about the region of it's densely populated, right? Does that mean there's overpopulation in the region? The environment might be kind of affected because there are so many people living in the area, cars, right? CO, carbon dioxide, the emission of carbon dioxide because of the amount of people living in their industries, right? The pollution industries can produce overpopulation because there are a lot of people living, right? And that overpopulation can lead to lack of jobs. Lack of jobs because there are a lot of people looking for jobs, and that can lead to shortage of jobs, right? So yeah, that I hope that makes sense. To move on, and an example of a densely populated location is Singapore, right? Okay, it's densely populated. We might see pollution, we might see overpopulation, we might see lack of jobs, but it's a very developed country. It's a very developed region, right? I mean region, sorry. If you look at the skyscrapers, right? You see how people are like jobs are kind of on top of each other, right? Because there's so many people, so many offices, so many businesses that are centered in there should be a way to make space, and that's like if you just look at that, if you just look at a place where like there are skyscrapers like that, you have to assume that the location is very busy and very populated because of the structure of the buildings and everything else around it. So carrying capacity. Carrying capacity. I'm pretty sure you guys are familiar with this. But carrying capacity is the number of people that can be supported without damaging the environment. So that means that each region, each country, each environment has a different carrying capacity depending on the resources available, right? And the technology and the other stuff going on the economy of the country, right? So carrying capacity differs from region to region, yeah? But carrying capacity is the maximum number of people that the environment and the economy and the services in a region can support without putting stress on the environment and the resources available. So exceeding the carrying capacity can result in damaging the environment, right? Damaging the environment, death of people, even the death of people. We'll talk about the COVID-19 in the next slide. About it's kind of similar to carrying capacity. We're talking about carrying capacity of our healthcare system, which is very similar, right? It's very similar. It's a great comparison. It's basically the same thing, but we're applying it to our health system. So loss of arable land because there's so many people, right? So there's so many people, many people want demand food, right? They need food to live, right? So there's gonna be more stress on the land. On arable land is a land that can be used for cultivation. So there will be stress on the land, and that will cause malnutrition. It would cause the loss of nutrients, and it will be harder for the soil to kind of replenish again, right? And to produce good crops. So, and then lack of food, yeah, because of the lack of arable land, there will be lack of food. But carrying capacity can be kind of made it can be expanded based with technology, right? With technology, for examples, the lack of food and loss of arable land can be resolved, right? Can be resolved because of all the fertilizers and all the chemicals we have came up with to kind of fix the soil, right? The soil that's dead, so it can produce more food, right? Damaging the environment, we also have been using some solar energy, so that's a way we can fix the environment with overpopulation and other people living in it. So sorry guys. Okay. Okay, so now we're talking about carrying capacity of a healthcare system, right? You guys have seen this curve, hopefully, of COVID-19. So basically the same thing here, right? So the carrying capacity of a healthcare system, that means how many like hospital beds are there available for sick people, right? How many hospital beds, how many nurses, how many doctors, how many healthcare equipments there are, like ventilators, for example, is very important for COVID-19 patients, masks for doctors, other equipments, right? If like the different like the curves, right? We're talking about the curves over here. I'm pretty sure, guys. I mean, it's not necessary to talk about it right now, but we're talking about we're talking about the graphs. So we can just talk about the curves really fast. The lower curve basically is slowing down the rate by which people are getting infected, by the same people are getting infected. This is a way so our healthcare system can kind of cope with the with the problem, with the crisis, and so our healthcare system can support that many people getting sick. But if you look at the bell-shaped curve, if you don't take protective measures, right, more people are gonna get sick and very fast. So our healthcare system will be overwhelmed, and doctors and hospitals will not be able to support that many people getting sick. So many people will die because our healthcare system cannot really support them. There are no enough supplies for that many people getting sick. So yeah. Now we're gonna be talking population densities, right? So population densities, like the general definition of that, is the number of people occupying an area. There are three different densities we're gonna be talking about. We're gonna be talking about arithmetic density, agricultural density, and then physiological density. And okay, let's do some questions. Can you guys tell me one of the definitions of each one? Choose one of the population densities and tell me what you guys know about it. What is it like? What is it? What is it? What is arithmetic? What is agriculture? And what is physiological density? You guys should you guys have to be familiar with this by now. It's unit 2. This is unit 2 review, so you guys have been familiar with this. I mean, you've covered it in your class last semester. Yes, that's right, Sarah. Arithmetic is people per area, and agriculture farmers per arable land. And then we have physiological. Yes, people per arable land. Good job, Sarah. So that is right. We will review that too, and then we will talk about what does that tell us about the resources, again, the development level of the country, right? What does that tell us? What does that tell us about the stress people are putting on the environment in that region, right? What does that tell us? Just a second. Okay, sorry for that. Okay, so physiological density is the number. Why do we start with physiological? It's weird. Okay, we'll talk about arithmetic first. Okay, so arithmetic density is the number okay, arithmetic density is the most used density kind of, because it's very easy to like get, right? You basically, the formula of it is basically dividing number of people by the land area of the country, right? So, but this also includes land that is unoccupied, right? So if the country has a lot of desert in it, nobody really lives in the desert, right? But that's still calculated, right? That's still calculated as the area of the land. So it kind of does not really give an accurate representation of how people are living or clustered. If that makes sense. eh, I don't want to say that because it does really give an accurate representation, but that's the thing. It might be inaccurate because of that, because it includes land that people do not live. But like, in how many countries do we have deserts, right? Well, we have a lot of forests and all. So yeah, that's just a thing to consider. It's not, but it gives us a very, like, for example here, it gives us very accurate representation of how people are living. So for the U.S., right, the U.S.'s arithmetic density is 80 persons per square mile, as opposed to China. China has 375 people per square mile. That's more than 4 times our arithmetic density. So people in China are more popular. There are more people living in China. Like, there's more people living in China per square mile than the US. So that tells us, right, people are clustered together. People are living very closely together because of this, because of how many people are living per square mile. And then, okay, we'll talk about physiological density. So physiological density is the number of people living per arable land. And the formula of that is basically dividing the total population of the country by the area of the arable land in the region. An arable land equals the suited arable land is basically the land suited for agriculture, right? The land that's able to support people by producing food, right? So this physiological density basically tells us how much food do we need to produce per unit, right? Per unit, square, whatever, kilometer, whatever, right? So if the physiological density is higher, that means that the land needs to produce more food to support the population in the region, right? But if physiological density is low, that means, okay, no, that's not right. I'm sorry, guys. I'm sorry. That's not right, because actually, no, that is right. No, no, that's not right. Wait, guys, I'm thinking. I got them confused. I got physiological and agriculture confused. So, okay, so if we have the U.S., right, we have 172 persons per square kilometer of land. So we have, okay, so in the US, we have a lot of arable land, right? We have a lot of arable land, we have a lot of people. So because we have a lot of arable land, the physiological density is low, right? Because the Midwest is all arable land, right? The Midwest is arable land. It's a big area, right? So because we have a lot of arable land, we have a lot of people, but we're dividing by a bigger number. So the physiological density is lower, right? Physiological density is lower, as opposed to Egypt, right? We don't have the population of Egypt, of course, is not close to the U.S., but they don't have a lot of arable land. If you look at the at the graph at the map to the right, you see that most of Egypt is kind of a desert, and people are basically populated around the red, like if you see the red line going down to the south, right? That would be the Nile River. So people are just populated around, not people, okay, the farmland is populated around that, but they don't really have a lot of farmland. So the small farmland they had has to support so many people. That's why the physiological density is high. So that tells us that they have to, their their square kilometer of land has to produce so much food than our square kilometer of land because they have so many people. Okay, so we're gonna be comparing comparing Egyptian versus the US densities, right? So no, we're gonna be talking. Okay, sorry. We're gonna be comparing Egyptian densities, right? The arithmetic and the physiological. So, so what is these numbers tell us about the clusters and the availability of resources, right? We have arithmetic 80 per square meter, right? Versus the physiological is very high, 2,295 persons, right? What does that tell us, right? 80 88 people per square meter is not a lot. It's not a big number, right? But the high physiological density tells us that there is so much stress on the land, right? So that can lead to problems like the lack of resources, deforestation of the land, because there's so much stress on the land. The land is needs to produce so much food, and that might result in Egypt maybe needing to trade, right, import food from outside because they're not able to produce food themselves. Are there any questions, guys? By now, anything about we've covered about physiological and arithmetic densities, you guys are able to identify the difference between them and what they tell us, right, about the region? Any questions? No questions? Okay, we'll move on. Okay, so agricultural density. This is okay. Agricultural density is basically the number of farmers per arable land. So this basically tells us. Okay, I want you actually tell me, guys. The U.S. has 1 farmer per square kilometer, while Egypt has 825 farmers per square kilometer. What does that tell us? What does that tell us about the agriculture of the region, the type of equipment used? What does that tell us? Type something in the answer box, guys, please. Let's get some interaction in. What does the high and the low agricultural density tell us? Yes, sir, that's right. That's right. So the US has more technology, right? And 1 farmer can produce so much more like food than an Egyptian farmer. But that does not mean because a US farmer is more skilled and stuff like that, right? Because the US has technology, right? We have like the technologies used in agriculture. They make agriculture faster and more efficient. So that leads to people. That means that not a lot of people in the US need to be farmers, and that leads to specializations in other sectors of the economy, right? You don't like in Egypt, you had 825 farmers per square meter. In the US, you only need 1 farmer. So these 26 farmers can do so much. 25, because right, 25, 825 farmers can be working in other parts of the economy, and they can specialize in other things to contribute, right? So that's the physiological density basically tells us about the about how it develops. I think it's the great representation of the development of the country. I would say, but again, not like you can't really just see that because a lot of regions don't really have farmland. A lot of small countries that are very developed don't have farmland, so they have to import food. So there are multiple factors you have to look at, not just. But like if you're comparing country to countries like that, it would make sense. It would be an accurate, I think, representation. So so what is this? Yeah, so we're talking about how the U.S. has more technology, more machineries, more resources, and then as opposed to Egypt, they need more manual work. That's why it's taking longer and it's less efficient. And then specialization basically occurs in the more in the U.S. because there are less farmers needed for work. And we are done for today. So weekly calendar, right, guys? Don't forget to show up on these streams on Mondays, math and English, Tuesdays, social sciences, Wednesdays, sciences, and Thursdays, history. Do you guys have any questions about anything, guys? We still have a couple of minutes. I can stay on. We can talk about whatever you guys want. Any question about anything? Test related? Other content related? Anything? Was this helpful, guys? Was there anything else you guys wanted to know about Any questions? No questions? I think there is something I wanted to talk about I didn't talk about. I think, okay, let me see. Let me go back to the slides. Okay, so I think two concepts I think that get confused is population density and population diffusion, right? Population density is how many people are living in a place, where population diffusion is how apart are those people living in a region. So they're not the same thing. Each one tells us different information about the they can be related, right? If you have a very low population density, that might mean, like we were talking about, that might mean that you have a lack of resources in special regions, and you might have to travel for longer distances to be able to access special like services, right? But they're not the same thing, and they tell us differently, right? They tell us differently about the a region, the structure of a region, and how research and the economy of a specific region. So that's all for today, guys. Don't forget to follow us at Fiveable at Twitter, Instagram, and YouTube. And again, there is something the project that Fiveable is working on. I forgot to put it on here. Sorry, guys, but it's called Fiveable Olympics, where it's a new project Fiveable is working on, and where basically you will earn points for the trivia questions and for the streams you are doing. So this is like a kind of motivation for you. Like there are 22 days, right? Left for you guys to study. So it's kind of like a good motivation for you guys to, it's kind of forcing you, or you can maybe basically compete with your other classmates, where you can compete, right, on points. Who will have more points by the end of the test or the end of the week, right? It's a good motivation for you guys, where you guys will earn points for the stuff you're doing on Fiveable, basically. So yeah, you guys should check it out. Amanda, pretty sure, has sent you an email regarding that. So check it out. It's kind of fun, especially you guys don't have anything to do at home. So it'd be a fun like competition kind of thing to study for the test and be ready for the test. And again, don't stress out about the test. You got it. Trust it. Just don't stress out, because stressing out makes it so much worse. If you have been doing all this work for the past year, for the past semester, I'm pretty sure you guys are ready to take the test. And just a quick like hint for the test: if you have two FRQs, right, or how many, whatever parts there are, if the parts are not connected, always do the one that you know. Always do the question that you know. For example, in the first question, if you have like multiple parts and then their parts are not connected, do the ones that you know, and then go back to the ones that you don't know, because you need to do well on the things to earn the most points you can by writing about the things you know. And if you have extra time, you can spend it on guessing or on the things you don't know. So that's another point, a very important, I think point on to know for the test. So yeah, that's it for today. I hope all of you guys have an amazing day, an amazing week. Stay healthy, stay safe, and keep your social distancing. Bye, guys.